On September 14, 2015, for the first time in history, we witnessed a ghost. Not the supernatural kind, but an actual physical phenomenon predicted a century ago by Albert Einstein. It was the first direct observation of gravitational waves, ripples in spacetime caused by the most violent events in the universe. And you can hear them coming all the way from Earth. You see, the universe doesn't just hold still. All the matter and energy in it constantly jostle around, creating a kind of constant hum. Normally, this is unnoticeable. But when something really big happens, like the collision of two black holes, it creates a blip in this hum, a ripple that travels outward at the speed of light. This ripple is a gravitational wave. These waves were first predicted by Albert Einstein in 1915 as part of his general theory of relativity. According to his equations, gravity isn't a force, but a curvature in spacetime caused by mass. So when two objects with mass move around, they disturb the spacetime around them, creating waves that spread out like ripples in a pond. But despite being predicted over 100 years ago, we didn't actually have any confirmed evidence of gravitational waves until that day in September. That's because they're incredibly hard to detect. Even when they reach Earth, they're extremely weak and distort space by only an atom's width, which is why we didn't notice them. Until 2015. On that day, the Laser Interferometer Gravitational-Wave Observatory, or LIGO, made the first ever direct detection of gravitational waves. LIGO is a massive instrument located in both Hanford, Washington and Livingston, Louisiana. It works by splitting a laser beam in two and sending each half down a 4-kilometer-long tube. The beams bounce back and forth off mirrors at the end of the tubes and then recombine. Normally, the recombined beams cancel each other out. But when a gravitational wave passes through Earth, it disturbs the spacetime, creating a change in length of one of the tubes by a fraction of a nanometer. This tiny change causes the interference pattern of the beams to shift, which can be measured by very sensitive detectors. The gravitational wave event detected by LIGO on September 14, 2015, was designated GW150914. It was caused by the merger of two black holes, each about 30 times the mass of the Sun, located 1.3 billion light-years away. As these two massive objects spiraled into one another and eventually collided, they released a tremendous amount of energy in the form of gravitational waves. These waves traveled across the universe and were finally detected here on Earth. The discovery of gravitational waves was hailed as one of the most important scientific achievements of the 21st century. It confirmed a major prediction of Einstein's general theory of relativity, published a century earlier in 1915. Although gravitational waves had been indirectly confirmed before through observations of binary pulsars, this was the first time they had been directly measured, proving their existence beyond doubt. The discovery was announced to the world on February 11, 2016. And ever since, we have detected many more gravitational waves, each one bringing us closer to understanding the most extreme environments in the universe. In 2017, the Nobel Prize in Physics was awarded to Rainer Weiss, Kip Thorne and Barry Barish for their contributions to the LIGO project and the detection of gravitational waves. Without their hard work and dedication, we might still be in the dark about this amazing phenomenon. But thanks to their efforts, we now know that spacetime is indeed dynamic, curving and warping in response to the mass and energy contained within it.